Hello, finance students. Today we're going to talk about the capital asset pricing model. And so to set that up, I just am going to do a little bit of a chalk talk here. We're gonna draw some pictures to help sort of understand what's going on. So I'm gonna make a plot first. So this is like a scatter plot, right? So if I have, and so here's my y-axis, and here's my x-axis. And you might be used to seeing something like, okay, maybe we could put height down here, and we could put weight over here. And then you'd get some dots. Right, and then we'd get a correlation line or something like this. Right, so this is the kind of plot we're doing. Just a scatter plot, one thing against something else. And so obviously though we're not going to do height and weight. So we are interested in two things. So the first is standard deviation. So this is the concept from statistics, right, where a random variable can have a wider dispersion of outcomes if it has a wider standard deviation, and it can have a narrower dispersion of outcomes if it has a narrower distribution, and a smaller standard deviation. And this is going to be our measure of risk for this discussion. Now, you can ask, why is standard deviation our risk measure? This is actually not true generally. For example, if I have a security that does like kind of okay most of the time, and then occasionally really terrible, that's a lot worse than a security that does, usually not so great and occasionally incredibly awesome. And for most people, that depends on preferences, but skewness and kurtosis, the other higher moments of statistical distributions, do matter for asset returns. But if we want to keep things simple, this is the standard deviation would be the best statistic to use if we had to use only one, right? So if we had to restrict it to just one, this is the one we would pick. So that's what we're going to be working with. And then on the other side is return. Okay, and if I'm going to be really clever, maybe I can get it to rotate. Here we go, let's see. Rotate, there we go, rotate. Left or right? Left. Okay, good. And we'll move it. There we go. Look at how fancy that is. Okay. So I have standard deviation and return. And so if we think about a different financial securities, so let's say we've got, and we'll do this in crayon just to keep it real. Whoa. Okay, well, let's see what happens. So suppose I've got a stock, right? And different stocks have different returns, right? If I have a risk, if I have a And generally, right, the riskier the stock, the greater the return, but it's not perfect. So we can kind of just map every stock with its return level and its risk level. So let's say we've got a stock that is kind of high return and high risk, right? We'd put it over here. And then maybe a stock with a lower return might have a little less risk. You can put that here. Okay. So what we can think about, right? So, so let's see. So we're going to label this, right? So this is stock A, and over here is stock B. You have these two stocks, and we could buy one or we could buy the other, and it would depend on our risk preferences, right? If I had to choose between 100% in A and 100% in B, if I was a risk-tolerant person, I would probably choose A, and if I really didn't like risk, I'd choose B. But the reality is we don't have to choose between them 100%. Right? For example, we could mix A and B 50%. And so if B has a return of, say, 4%, and A has a return of, say, 8%, if I mix them 50-50, what do you think I'm going to get for my return? Well, it's just like you'd expect. Halfway between them is 6, and so you'd get a blue dot at 6%. And if I drew a line here, like, you know, here across in the middle, they would be somewhere in here. Now, standard deviation, right? If this is standard deviation, an annual standard deviation of, say, 22%, and this is an annual standard deviation of, say, 25%, you'd think, well, maybe it is, if I'm halfway in between here, maybe I'm halfway in between here and get 23.5. Okay, I'm not going to write that number because this is not the case. And the reason is that when you take two random variables and combine them in a portfolio with weights, it actually matters the covariance between those two assets, the correlation between the assets. Okay, so if the assets are perfectly correlated, right? If A is up when B is up the exact same amount, and if A is down when B is down the exact same amount, then the standard deviation will be exactly in the middle. But this is generally not the case, right? That's like a worst case scenario. Sometimes A will be up and B will be down, and sometimes B will be up and A will be down, and the variability will kind of cancel each other out. Not all the time, but some of the time. And since the worst case scenario where it never cancels ever is exactly in the middle, the truth is going to be somewhere less than that, right? So if this is the worst case scenario right here, right? This is the super horrible spot, as bad as it gets, reality is not going to be there. It's going to be somewhere in this direction. Okay, so we can think about drawing another dot. I'll make this one green. Maybe over here, that's the actual result. Okay, and that one could be at 20. Okay, now this, you might be thinking, well, gee, is it possible that half A and half B has a smaller standard deviation than either A or B? And the answer is yes, yes. It can have a smaller standard deviation than either one, and that's because of this risk canceling that happens sometimes, right? So A and B being average requires perfect correlation. Generally, we have much less than perfect correlation in real life, and so often a 50-50 mixture of A and B will have lower risk than either A or B. Also, right, this week we did a 50-50 mixture, but we didn't have to do a 50-50 mixture, right? We could have done a different amount. And so reality is we could have done 75-25, up closer to A. We could have done 25-75 down closer to B, or anything in between. And so actually, if we want to, we could draw a plot of all of the different possible portfolios. So we could, we'd be drawing a picture something like this, or these are all the different potential portfolios. And so when we do these pictures, we actually usually just draw a curve. So, oh, horrible. Let's see. Maybe I think there's a curve tool. Here we go. See if I can do this. See how I'm doing. Oh, gotta pull it up. Oh, pretty close. Okay, pretty close. There we go. So now we've got this curve. And remember, these are all the possible combinations of A and B. So up towards the top, we're almost all A. Down towards the bottom, we're almost all B. And this is everywhere in between. Okay. And so this is sort of the beginning of thinking about portfolios. So now we're investing in portfolios, and they have different properties than the individual securities. So now I'm going to add a bad asset. Okay, let's get our crayon out again, and I'm going to add a bad one. All right, so where is a bad asset on this chart? A bad asset would have lower return than A or B and higher risk than A or B. So we'll put it right here. All right, there we go. It's bad. This is bad. And we'll label it C. Oh, in black. Okay, so this one's bad. So you'd think, wow, so C is clearly worse than A, and it's clearly worse than B. right? It's got lower returns and higher risks and everything. So I would never invest in C. And that turns out to not be the case some of the time. So what can happen, right? What can happen is we get out our curve, right? So I have my AC here, okay? But this is going to curve to the left, and maybe this one curves a lot. Something like this. Right, maybe something like that. Okay, now notice we still wouldn't buy any of these, right? Everything on AB is still better than everything on AC. But there's one more thing we can do. We can combine a portfolio in AC with a portfolio mix of AB. So maybe I am combining these two portfolios here. And you know what? Let's do this in a different color. Why are we doing a different color? Because this is a portfolio of portfolios. I'm mixing this one and this one. So if I mix this one and this one, I might get something like this. Oh, well, that was not what I wanted to do. Okay, Mr. Curve. One more time, and then I'm drawing this like a normal. You're probably thinking, what is this guy doing? All right. Boom. Like that. I'll make it thicker. Okay. So now, right now we've done even better, right? If by mixing in C, we can get to somewhere over here, and that, like this spot right here, has the lowest risk of anything we have so far. Okay, now what decides how big this is? Why didn't this just look like maybe this instead? Okay, the reason is correlation. So the smaller the correlation, the more that this portfolio arc will swoop to the left. In fact, if you have a perfect negative correlation, it would look like this. And you go all the way to no risk. That's what perfect negative correlation would do. So generally, we don't have perfect negative correlation, so it swoops somewhere less than that. But you can have less correlation or more correlation depending on the kinds of assets. Okay, so you can imagine, right, that I could do this lots of times. There's lots of different financial investments I can buy in the marketplace. So I'm going to start drawing these red lines here. Right? And so maybe there's another one down here that I combine to do this, and maybe there's another one sort of over here that I combine that can go like this. And so you just keep adding these things until eventually you've put everything in. So let's say you put everything in, and no matter what we do, it just stops getting better. Right? We can draw a lot of these lines, so we're mixing lots of stuff. We're mixing lots of things, and it just doesn't get any better. There's a limit. There's a limit to how much you can do this. And so once you have every single risky asset in the economy, so there's blue dots, right? There's blue dots all over here, right? We got blue stuff everywhere, and we've mixed them all, and we've done all the mixing we can. We've mixed the mixes. We've mixed everything. Once you've done that, then you've achieved something special. So we'll draw that right here, right? This guy right on the outside. Oh, maybe I can use a paint bucket. That'd be fun. This guy right there, fail. That guy on the outside that I will draw with my plain old pencil. This one right here is special. We'll make it here. This will go Super Saiyan. This one right here is the efficient frontier. Efficient frontier. Okay, black, please. Black. No. Efficient frontier. So, what is the efficient frontier? The efficient frontier is the maximum achievable risk-return trade-off, the best one for every level of return, right? So for every level of return, we have the lowest risk we can achieve, mixing the best we possibly can. Okay, that's the efficient frontier. And so if I am, it's pretty much the smartest portfolio you can invest in under these assumptions. And so if I don't mind risk very much, I will be way up here at the top. So I'll invest up here because that's where you get really high returns. If I don't like risk, maybe I'll invest down here. Now down here, right, we can invest down here, but it's kind of silly, right? Because if I'm going to take this much risk, I might as well invest up here. Okay, so that bottom part of the efficient frontier down here is, it's still on the frontier because it's still the lowest risk level you can get for that level of return, but it's not really investable. You wouldn't invest down here. So the invest, if a rational investor would invest somewhere between here and up here, in here. This actually would continue on, and so I'm not drawing it out here, but if you wanted to have crazy risk, then it'd be out here somewhere. But people generally aren't that risk tolerant. So at some point it gets to be so much risk that no one's willing to put up with it, and it just is not really investable for that reason. Okay, so that is the description of the efficient frontier and how we get there. So when I come back and do the next one, we will add a risk-free asset and see what that does.